Okay, so let's talk about rational functions. Okay, so rational functions means we have a px over qx. Okay, so a polynomial over a polynomial. So for example, we have x squared minus 1 divided by x squared plus 3x plus 2. So that's a rational function. So either example, x minus 1 over x plus 2. That's another example. Okay, and we may also have x plus 3 over 1, so which is x plus 3. So polynomial is a special case of rational function. Okay, rational function. Or we have 1 over x plus 3. Okay, so we have these examples of rational functions. The numerator has some x, denominator has some x. And today we will talk about multiplication and divisions of rational functions. So before that, let's go back to factoring. Okay, so factoring is the key. So we have some basic factoring ideas. Okay, basic factoring ideas. So the first important formula is a squared minus b squared is a plus b times a minus b. Okay, so we can use a square minus square. We have this formula for square minus square. So we can get a plus b times a minus b. Okay, so for example, we have x squared minus 4. How to find factor x squared minus 4? Use this formula, right? So what is a? A is x, and then b is 2. Okay, so we have two second powers, perfect squares, and then we can use their square root to get conjugate, multiplication of conjugate expressions. Okay, so it's a plus b, so this is x plus 2. A minus b, so this is x minus 2. Okay, x minus 2. So this formula is a very important factoring method. Okay, factoring method. So the second factoring method is the trial and error method. Okay, so for example, we have x squared plus 7x plus 12. Okay, plus 12. So the condition is if a is 1. Okay, so we have ax squared plus bx plus c. We want to factor some expression like this. If a is 1, so a is 1 means 1x squared, right? And we can use try and error method. Okay, so we assume we can factor this as x plus s times x plus t, right? So what's the product? The last number is the product. S times t is 12. So what's the sum? This is the sum. S plus t is 7. Okay, so we have a product condition and a sum condition for this special case factoring method. Okay, factoring method. So we need two numbers. Product is 12, sum is 7. So what are these two numbers, right? What are these two numbers? So we list all the possibilities for 12. Okay, s times t is 12. So 12, it could be 1 times 12, 2 times 6, 3 times 4, right? And they have some negative numbers. So what's the sum? We check the sum to get 7, right? So sum, this is 1 plus 12, 13, wrong. 2 plus 6, 8, wrong. 3 plus 4 is 7. So that's our answer. So S is 3, T is 4. Okay, so we list all the possibilities for the product and then we check the sum. So x squared plus 7x plus 12 is x plus 3 times x plus 4. Okay, so that is the easier case of trial and error method. Okay, trial and error method. Now let's look at a harder case. Okay, a harder case. So if you are very good at trial and error method, you can also use trial and error if a is not 1. Okay, if a is not 1. So let's look at this example. So we got 2x squared minus x minus 3. Okay, so now a is not 1, so this is not x and x, so this will be 2x and x. So we'll split x squared to 2x squared to 2x and x. And we also split 3. Okay, so when we split 3, we have several cases, right? So what is negative 3? So this is -3 is our product, just like the previous case, okay? The product is -3, the sum is -1, okay? So this is still the product. And this is the sum. The sum in FOIL method, okay? So that's the difference, okay? That's the difference. You cannot just use S&T here because A is not 1, so it's the sum of FOIL method. Okay, so -3, we got two cases, 1 times -3 or -1 times 3. So -1, +3 here, or 1, -3. Okay, 1, -3. So we have two cases, so let's check it by FOIL. We check the sum of the middle two terms. If we get -x, that's our answer, right? So we got 2x minus 1 times x plus 3. So outer product O plus I, the inner product. Okay, so that's the middle one. Okay, that's the middle one. So F is 2x squared. L is -3. Okay, -3. So 2x times 3, we got 6x. -1 times x minus x. So the sum is 5x. It's not -x, so this is wrong. Okay, so let's check the other one. So 2x plus 1, x minus 3, right? X minus 3. So we have the same F and L. So 2x squared, -3. So O and I, right? This is O and I. Okay, O and I. So now what do we have? 1x and then -3. So we got positive x minus 6x, so we got -5x. So this is also wrong. Okay, this is also wrong. Okay, so now we have to switch 3 and 1, right? Let's switch 3 and 1. So for harder cases, if A is 1, A is not 1, trial and error method also not very easy. Okay, so now let's put 3 on this side and 1 on that side. So we may get -3, +1, or +3, -1. Okay, -1. So now let's check the third case. 2x minus 3 and x plus 1. 2x minus 3 and then x plus 1. So this is F is the same, L is the same, 2x squared, -3. So what's the O term? So this is inner product, this is outer product. Outer product 2x plus 1, so this is 2x. Inner product, -3x. So positive 2x, -3x, we got -x. So this is -x, their sum. The sum of O and I is -x, so this is the right answer. Okay, this is the right answer. So this is 2x minus 3 times x plus 1. Okay, x plus 1. So if A is not 1, we can still use this idea to factor product and sum idea to factor the quadratic polynomial. Okay, quadratic polynomial. So now the worst case, okay, the worst case, so you should consider quadratic formula. Okay, if you cannot factor it, you cannot use, so let me repeat, right? Ax squared minus b, a squared minus b squared is a plus b times a minus b. So if you cannot use this one, you use sum and product. Trial and error, right? Trial and error. And number 3, the third case, use quadratic formula. Okay, use quadratic formula. So the last case, we use quadratic formula to factor if number 1, number 2 doesn't work. Okay, number 1, number 2 doesn't work. So now let me try the previous example by using quadratic formula. Okay, we want to factor 2x squared minus x minus 3, right? Minus 3. So what is ABC? A is 1, B is -1, C is -3, right? -3. So by the quadratic formula, so let's put quadratic formula on top. -b plus minus negative b plus minus square root of b squared minus 4ac divided by 2a. Okay, divided by 2a. So b is negative 1, so negative b is positive 1 plus minus 2 times 1 on the bottom. Okay, so negative 1 squared minus 4 times a is 1, times c, right, times 4ac. So this is negative 3. Okay, negative 3. Sorry, there is a mistake, right? A is 2. Okay, a is 2. So here is 2, and this is 2. Okay, this is 2. Okay, so now we have 1 plus minus. So what's this radicand? Is 1. This is 4 times 2, 8. 8 times 3, 24, plus 24, so it's 25, divided by 4. Okay, divided by 4. So we got two solutions. So x1 is 1 plus 5 divided by 4. x2 is 1 minus 5 divided by 4. So this is negative 1, and that is 6 over 4, so this is 3 over 2. Okay, it's 3 over 2. So we got two solutions. x1 is 3 over 2, x2 is negative 1. Okay, negative 1. So how to use quadratic formula to factor? Let me put up the formula, okay? ax squared plus bx plus c is ax minus x1 times x minus x2. So this is the formula for the quadratic formula. We use quadratic formula to factor, okay? Factor. Okay, x minus x1 times x minus x2, and then there's a here. Okay, there's a here. So now let's plug in. So this is 2x squared minus x minus 3 is 2 times x minus 3 over 2. And then x minus negative 1. Okay, negative 1. So now let's simplify this a little bit. Distribute this 2 to cancel denominator. So we got 2x minus 3 here. And then this one becomes x plus 1. Okay, x plus 1. So we got the same answer by using quadratic formula. Okay, quadratic formula. Okay, so that's our factoring part. Okay, factoring part. So we use half lectures to explain 3 methods to factor. Okay, to factor either square minus square, a square minus 8b square, or trial and error, or this quadratic formula for the hardest case. Okay, for the hardest case. Okay, yeah. So now let's talk about multiplication and division of rational expressions. Okay, so let's look at our first example. Okay, our first example. So let's look at an easier one. So x plus 2 over x minus 1 times, this is x squared minus 1, x squared minus 4. Okay, minus 4. So this is a rational expression. This is another one. Okay, this is another one. Okay, yeah. So now let's factor the quadratic part. Okay, factor the quadratic part. So we keep the first one, x plus 2, x minus 1 times. So we use this formula for the numerator and denominator for the second fraction, right? This is a plus b times a minus b. So this is x squared minus 1. So a is x, b is 1, right? So here, for this one, for this example, a is x, b is 1. Here, a is x, b is 2. Okay, because 4 is b squared, right? 4 is b squared. So on top, we have x minus plus 1 times x minus 1. And on the bottom, x plus 2 times x minus 2. Okay, x minus 2. So we factor that numerator to get this, factor denominator to get x plus 2 times x minus 2. Okay, x minus 2. So now what's the multiplication rule for fractions? All right, let's look at an example. So you have 3 over 6 times 2 over 5. What's the multiplication rule? Top times top, bottom times bottom, right? This is 3 times 2, 6 times 5. And then we have some common factors we cancel, right? If you hear 2, so there's 1 is 3, and then 3 is 3 canceled. You got this is 1 over 5. So now here we use the same idea, okay? So numerator times numerator, denominator times denominator, and then cancel common factor. So top, we have x plus 2 times x plus 1 times x minus 1. Denominator, we have x minus 1 times x plus 2 times x minus 2. And then we can cancel. They canceled. So the answer is x plus 1 over x minus 2. Okay, over x minus 2. So this is the multiplication idea. Okay, this is the multiplication idea. Okay, yeah. So when you practice online, they may also ask you, so what's the number that is not in the domain? Okay, or x cannot be one number. So the one number has to be excluded. Okay, it has to be excluded. So let's talk about that a little bit. So this expression, this calculation is true for all the x except denominator is zeros. If denominator is not 0, we can use this expression. Okay, all the calculations are correct. Because if denominator is 0, then the fractions has no meaning. The division has no meaning, right? So this denominator, so x minus 1 is not 0. The second denominator, x squared minus 4 is not 0. So x is not 1. For the first denominator here, we use this factoring idea, right? So this is x plus 2. X minus 2 is not 0, so x is not negative 2, x is not 2. Okay, so all the calculations are correct except these three numbers for x. Okay, when x is not 1, not 2, not negative 2, we can use factoring and common denominator, cancel common factors. Okay, cancel common factors. So that's the remark. Okay, that's the remark. So for all the questions, you have to be careful to make sure denominator not 0. Okay, yeah. But sometimes we just forget about this information. Okay, some whiteboard questions, they will ask you. Okay, so this is true except which numbers? So that means we need to know denominator not equal to 0. Okay, denominator not equal to 0. So let's look at another example. Okay, let's look at another example. X plus 2 over x minus 1 times 1 over x squared plus 3x plus 2. Okay, plus 2. So this is the only term that we have to factor. Okay, degree 2 term. Okay, degree 2 terms. So x plus 2 over x minus 1, you keep it. So how to factor that? Trial and error, x squared plus 3x plus 2. So we need two numbers, product 2, sum 3. So this is 1 and 2. So this is x plus 1, x plus 2. Okay, x plus 2. So x plus 1 times x plus 2. Okay, x plus 2. And then multiplication means you put everything together on top, everything together in the bottom. And then cancel common factors. They canceled. So the answer is 1 over x minus 1 times x plus 1. Okay, x plus 1. So if this is a function, this is called the domain of the function. So now we don't use function. So this is for this expression, denominator cannot be 0. So x minus 1 is not 0. And this one is not 0. Okay, so that implies x plus 1. So this is x not equal to 1. X plus 1 times x plus 2 is not equal to 0. So x is not negative 1. X is not negative 2. Okay, it's not negative 2. But again, most cases, we can forget about this kind of calculation about denominators. This is our assumption. X are not these numbers. Then we have the calculations on this side. Okay, on the left. Okay, on the left. So this is multiplication. Okay, this is multiplication. So now let's look at division. Okay, let's look at division. Let's look at two division examples. Okay, two division examples. So this one, x squared minus 4 divided by 4x squared minus 9. And divided by x squared plus 4x plus 4 over 2x squared minus x minus 3. Okay, minus 3. So for the numerator and denominator in the first fraction, we use this for factoring formula. Okay? Yeah. So on top, A is x, B is 2. On bottom, A is 2x, B is 3. Okay, B is 3. So we got x plus 2, x minus 2. On top, 2x plus 3, 2x minus 3 on the bottom. Okay, on the bottom. So now what's the division rule for fractions? Okay, for the division rule for fractions. Again, so let's look at fractions, right? 1 over 2 divided by 1 over 3. So what should we do? So we flip this and then change it to multiplication. Just flip it, okay? So it's 3 over 1, okay? 3 goes to the top, 1 goes to the bottom. 1 over 3, flip it, you got 3 over 1. And then top times top, bottom times bottom. So it's 3 over 2, okay? 3 over 2. So now we use the same idea, change it to multiplication by flipping the second fraction. So we just flip it. Okay, flip it. So now the main question is, can you factor this new numerator, and denominator for the second fraction? Okay, second fraction. So we already did this numerator. Okay, I used trial and error and quadratic formula, right? So we got 2x minus 3 times x plus 1. That is this numerator. And denominator, so we can try it. X squared plus 4x plus 4. So s times t is 4. S plus t is 4. So s is 2, t is 2. Okay, so it's 2 and 2. Okay, so it's 2 and 2. So now let's rewrite it. X plus 2, x minus 2. I just copy the first one. And then the second one, we got 2x minus 3, x plus 1. And then the bottom is x plus 2. S is 2, t is 2, x plus 2. Okay, s plus 2. So now multiplication rule. Top times top, bottom times bottom. So that's the big fraction after the multiplication. Okay, yeah. So now cancel common factors. 2x minus 3. Minus 3. So I cancel the wrong one. Here, 2x minus 3, 2x minus 3. X plus 2, x plus 2. Okay, so the answer is x minus 2 times x plus 1 divided by 2x plus 3 times x plus 2. Okay, x plus 2. So that's the division. Okay, that's the division. So we flip the second fraction, change division to multiplication. Okay, flip the second fraction. Okay, flip the second fraction. And then we got the answer. Okay, flip, factoring, factor, and then cancel. Okay, then cancel. The last example. Okay, one more example. So 5x divided by x plus 4. This is the first fraction divided by another fraction. Okay, yeah. So now first we need to flip the second fraction to change this to multiplication, right? And to keep the first one because first one is linear. So now x squared plus 7x plus 12 on top. X squared minus 2x is on the bottom. Okay, is on the bottom. So for the top, we use s and t, right? S and t. Product s times t is 12. S plus t is 7. So s is 3, t is 4. Okay, we did it already. So that's our first or second example. So this is x plus 3 times x plus 4. Okay, x plus 4. For the denominator, x squared minus 2x. So we can factor out common factor. Okay, so sometimes this is also a good method for easier questions. Okay, easier question. Factor out x, we got x minus 2. Okay, yeah, it's just the reverse of distribution, right? Distribution. Okay, factor out common factor method. So this is x and then x minus 2. Okay, x minus 2. So now we put a longer bar, numerator times numerator, denominator times denominator. Okay, so that's the multiplication rule. So now let's cancel common factor. X plus 4 canceled. X and x canceled. So on top, we have 5 times x plus 3. On bottom, we have x minus 2. Okay, x minus 2. So that's the answer. Okay, that's the answer. So multiplication and the division are not hard. The harder part is the factoring part. Okay, factoring part. Okay, so next time we will talk about addition and subtraction. Okay, addition and subtractions of rational expressions.